Okay, here's example 2, chapter 26. It's very similar. It's another counter problem. It's similar to the previous example. So all these problems have the same type of information I'm looking for. Usually I'm looking for the top two levels, the black box diagrams. I'm looking for a schematic of both levels and properly annotated. And also, I forgot from the last problem, but I want to state how the circuit's controlled. So this is a similar problem. So let's do it. Okay, so this is another counter problem. It's not going to need a state machine because I can actually do a decent job of. I can actually implement without a state machine. So we can do it without a state machine. First thing to always do in all these problems is draw the black box diagram. This problem doesn't seem to have any control on it. Here's my circuit. Once again, it looks like a counter. It's counting through these two sequences in order. One of the sequences starts at 6. The other one starts at 3. But the maximum count for both sequences is 15. So this once again is going to give me a 4-bit counter. I'll throw the count in there. And so what's interesting about this, I think there's an LED output on this, so we better put that in. Actually, so I remembered this time. Certainly has the clock, and this one's a little bit different because it has a button input, and this button input is going to control whether I am counting from 3 to 15 or 6 to 15. So essentially, it's going to control the loading of the counter. So the heart of this problem is very similar to the last problem. Is going to be a counter, as we know and love it. The output here is count. There's my 4 bits. And what else do I have here? I have an LED output. Okay, LED looking good. So I'll have to remember to fill that in. Actually, it has a clock input. It's a synchronous circuit here, and the issue is for this circuit, I'm going to also use this RCO, which is ripple carry out, and it for similar to the last circuit, when this counter hits its terminal count, counting the up direction, which is up direction is 15. That RCO is going to turn on, and what I'm going to do, just like the last problem, I'm going to feed that RCO around to the load input, and it's going to load, and it's actually, I need to turn this up on, so it's always counting up, and which I forgot to do in the last problem, by the way. Okay, maybe I can go fix that, but total bummer there. But anyway, what's important with this problem is I'm going to load one of 2 input values to this thing. And so it's either going to be 0, 1, 1, 0, which is 6, or 0, 0, 1, 1, which is 3. So it's going to be loading one of those 2 values. And what's controlling that loading here is the button input. Okay, looking good. I need to put some zeros and ones to complete this mux. Got to read the problem again. The count sequence 3 to 15. Button pressed. 1 goes from the 3, so this is the 1 and the 0. And output goes here, which is the data input on the counter. And I guess I'm almost done with this problem. So this problem is a little bit different. I have this LED that turns on when the output is less than 8. So once again, I have 8, 4, 2, 1, which is the weightings of a binary number, 4-bit binary number. Okay, and the idea here is I'm working with a 4-bit counter here. So if this MSB here is turned on, that means the counter output is at least 8. So if this MSB is turned off, that means the counter output must be less than 8. So the trick on this thing is I'm going to grab the MSB on this thing. I'm going to invert it, and that's going to be my LED output. So I'll put this one MSB. And I think that's it for this problem. Life is good, I guess. Can't think of anything else. I think I remembered it this time. Unfortunately, I didn't on the last problem. And so that's it on this. I'm going on.